So in this reaction, we're told that this is a first order reaction. It doesn't really matter from here on out what it is. First order reaction with a rate constant K, which is equal to 6.7 times 10 to the negative fourth inverse seconds. Now, since it's first order, and we're going to be asked questions about its concentration at various times, we're going to need to have the first order integrated rate law. And I have that right here. That should be A naught. Let's make that look better. And so this is something you either will have to remember or you can look it up. They're not very difficult to remember if you practice with them enough. And so for this first question, I'm just going to plug in what we're given. So we're given K. So we're going to have minus, and it's 6.7 times 10 to the negative fourth. And we're told that we're looking at it at 30 minutes. Now, remember, the K unit was in inverse seconds, so we're going to have to change 30 minutes to seconds. So you multiply by 60 seconds in a minute, and so we'll have 1,800 seconds for our time. Now, we're told that the initial concentration is 0.05, so plus the natural log of 0.05 is going to be equal to the natural log of what we're looking for. And now you'll get a value on the right that you can plug into your calculator, and then you'll have to exponentiate both sides. So in other words, you have to take e to the power of whatever you get here, and that's going to give us the concentration of A, which I did that. I put it into the calculator, and I got 1.4 times 10 to the negative second molar. And that makes sense that it should go down from the initial concentration. Next question. Same sort of thing. Now we just plug in different things. In fact, I'll do it up here above so we can still see the integrated rate law. So this time, we're told that what the concentration we're looking for at that time t, which is 0.01. So the natural log of 0.01 is going to be equal to negative k. I'm not going to plug that in. We already know what it is. And t is what we're looking for, plus the natural log of the initial concentration we're given, which is 0.05. Now, you're going to be able to get a value over here, a value over here. You know k, so you'll get a value for t. Now, remember, since k is in seconds, or inverse seconds, the time t that you're going to get is in seconds. So in order to go from seconds to minutes, you're going to have to divide by 60. And when I did that, I got 1.4 times 10 to the fifth minutes. Okay, last one is actually really identical to the second part, but we're told that we're looking for 25% of the initial. And so the initial amount was 0.05. And so we want to divide by 4 to get 25%. And when we do that, we'll get that the final concentration we're looking for is 0.0125 molar. And now everything else is plugged in identically. So I'll work through that. It's the natural log of our final concentration, 0.0125, is equal to negative kT plus the natural log of our initial concentration, 0.05. And when you do that, remember, you'll have to take it from seconds to minutes by dividing by 60. But the time that you'll get is going to be equal to 2.6 times 10 to the fourth minutes. And that makes sense that it should be less time than it was in part B, because the final concentration we're going to is not as small.